You're welcome. Okay.
Morning. So I will talk about the validation stamping process. So it's very preliminary discussions we will need to have in the editor project forum, but I will give you the status. And so I will talk about the importance of the scientific validation, the existing protocols in the community, and what are the challenges and opportunities with the digital twin ocean, and what could be the first version of this validation stamp. So there are several validations needed to build a digital twin of the ocean. There's let's say IT validation. You need to respect the syntax, so you need to have a structure in your data, you need to have correct metadata, so that's important. But the quality validation, the validation of the scientific content is also very important, of course. This is to build trust, the trust of the users, of course, in the oceanographic data, the models and applications that we deliver on the digital twin. We need to measure quality also because we need to measure the improvements, the regular continuous improvement of what we are doing. We need to maintain the solutions, and we need to ensure that they are innovative. Depending if it's data, models, or applications, we may, the main conditions of trust of the users may be a little bit different, or there may be a slightly different focus. For data, they need to be state-of-the-art, accurate, and consistent. And for models, maybe we will first focus on being sure that they are evidence-based and peer-reviewed. And applications also peer-reviewed, fit for purpose, reliable, of course. So if we look at what is already used in the community for validating data, of course, there are examples of the Copernicus Marine Service and EMODNet. So Marine Service on the left and EMODNet on the right. And so these data services, as you know, already have user trust. Hopefully, I hope so, because we are working at it very hard in this room. And so Copernicus Marine and EMODNet both have quality assurance feedback loops involving the users and the producers in producing data quality information and quality flags for in-situ data for EMODNet and quality information for observation products and model products for Copernicus Marine. So the users know where to find the quality information. For the models, the validation protocols that exist, so it gets a little bit more difficult because there are many models, as we saw yesterday, many different models in the community that will be available in the digital twin ocean. So here I take the example of ocean physical forecasting models. There's this Ocean Predict international program. It's a collaboration program between ocean global forecasters for the physics of the ocean, and they have a protocol in place to validate and intercompare models and to ensure that they have a correct statistical behavior with respect to reference observations or with respect to the literature. They check the physical or the biogeochemical or biological behavior of ocean processes at all scales, and also the consistency of the variability and trends for the long time series, for instance. And this protocol is used, for instance, in the Copernicus Marine Service to follow the quality change in time of the model products, for instance. So we check we check every month that the model outputs, analyses, and forecasts do stay consistent in time, that they have the right statistical behavior with respect to observations. For instance, on this curve, you see the metrics that we follow with the color curves, and also the number of reference observations that we have, that we use to perform these statistics at the regional and global scale. We also use this protocol as a way to measure the operational readiness of forecasting systems. So it's a best practice that we share. For instance, here in the Ocean Prediction Decade Collaborative Center with the operational readiness levels. And we also use these metrics to perform benchmarking. For instance, here, this is Ocean Bench. It is a benchmark system for the AI-based forecasting systems that exist today in the community. For applications now, so it's even more difficult because applications are also based on models, and there's even a widest variety of applications and models in when you get closer to the coast or to final end users. And so it goes from maritime safety to biology, to ports, operational activities, so many applications. You can see here on this example coming from Eurogoose. So, of course, we need to be sure that there's a quantification on the uncertainty, but this is strongly depending on the available observations that we have to perform this uncertainty check. And here we need to use phenomenon-oriented metrics, so it is more difficult to automate, to imagine that we will have automated processes, but we can work at it. So we can rely on peer review as a first step, and we can also rely on user feedback, maybe, to understand if these applications can be stamped in a way. Then the what-if scenarios, we can imagine that we can check first if the question asked is relevant to the domain, as we said yesterday, and then if we can check the historical period, and also use peer review as a first quality stamp. But this is, I think, something that needs to be discussed within the project forum, and for this community to converge on processes that will be able to address all the multiple domains that are tackled within the digital twin ocean. So we have a lot of challenges because we will have to address regional errors, extremes, unobserved variables for models. We will have new data sources coming in like high-resolution satellite, new in situ ensemble model products, AI-driven models, and this will be an increased data volume and complexity, a need. While we need to have reproducible and transparent and scalable validation processes. So a lot of challenges, but also a lot of opportunities to harmonize, to intercompare, to automate the testing and the validation and the benchmarking, hopefully, and to scale also. The platform will also give us opportunities to exchange a lot with the users and to build together, to build trust and to build faster ways to adapt to evolving user needs. So for first version of a quality stamping, of course, we can rely on what is already validated. And so first, Copernicus marine data and IMODNET data can have a quality stamp, and we can also rely on a community approach and peer review to ensure that we propose models and applications that are trustable. And of course, we can work within the project to see how we can quality stamp applications or models that are within the community, but maybe not yet published or peer-reviewed, and contributions from a larger community, from the citizens, etc., using automated processes or other ideas that will come up within this new large community. So first, community validation approach, and then possibly automated validation with new cloud-based tools, benchmarking, and eventually we can imagine that the user feedback will also enter our validation stamping approach. So, thank you.
Super clear.